Picture this. You wake up one morning to the shocking news that a black hole, an incomprehensibly powerful and destructive force capable of bending space and time itself, is on a direct collision course with Earth, threatening to obliterate everything we know, cherish, and have built over the course of human history, while potentially reshaping the very fabric of our existence in ways we can scarcely comprehend. What do? Panic? Run? Fight back? Well, fighting back is the human way. We'll try everything we can think of. From launching nukes to creating antimatter, and even exploring wild ideas like using a white hole or time travel, we'll brainstorm every solution, no matter how crazy it sounds. But here's the big question. Can we really stop a black hole? Let's explore the possibilities and the science behind them. First, let's understand what we're dealing with. A black hole isn't just a big hole in space. It's a region of extreme gravity caused by the collapse of a massive star or a dense accumulation of matter. There are a few key parts. 1. The event horizon is the boundary where gravity is so strong, not even light can escape. 2. The singularity is the center, where all the mass is squeezed into an infinitely dense point. Black holes come in different sizes. 1. Stellar black holes are about 10 times the mass of our sun. 2. Supermassive black holes can be millions or even billions of times heavier. 3. Primordial black holes, which may have formed right after the Big Bang, are still a mystery to science. What makes them terrifying is their insatiable hunger. A black hole grows as it consumes matter and energy, leaving destruction in its wake. And if one is heading our way, Earth might just be a snack. Now let's get to the fun stuff, blowing it up. Earth's nuclear arsenal is massive. Combined, our 13,000 warheads could release more energy than 400,000 Hiroshima bombs. What if we aimed all of that at the black hole? Here's the problem. Black holes don't explode. They absorb. Even the massive energy from nuclear blasts would just be swallowed, adding to the black hole's mass. And if the black hole is moving fast, imagine a black hole hurtling through space at an incredible speed of 100,000 kilometers per second. If we launched all of our nuclear weapons at it, their immense power would barely make a dent on its surface before being completely swallowed, vanishing without a trace into the abyss. Nukes are no match for something that can bend space and time itself. Why are black holes nearly impossible to destroy? It's because of their nature. Imagine trying to fight a creature that gets stronger every time you hit it. That's a black hole. To destroy it, you'd have to remove its mass or reverse its gravity. But gravity at a black hole's event horizon is so strong that you'd need more energy than our sun produces in its entire lifetime. And there's another complication. Black holes don't just sit there. They warp space and time around them. Even if we aimed a weapon, the black hole's gravitational pull would distort its path. So any solution has to account for these extreme conditions. What if we fought fire with fire, using another black hole made of antimatter? Antimatter is the opposite of regular matter. When the two meet, they annihilate each other in a burst of pure energy. Theoretically, creating an antimatter black hole and colliding it with the one heading for Earth could neutralize the threat. But there are two big problems. 1. Producing antimatter. Creating even a gram of antimatter would take billions of dollars and years of effort. 2. Imagine trying to make enough to form a black hole. 3. The result? The energy from the collision would be catastrophic, releasing deadly gamma rays that could destroy Earth anyway. Although the concept is fascinating and holds immense potential, the reality is that achieving this is an enormous challenge, as it lies well beyond the capabilities of even our most advanced technology today. The resources, expertise, and advancements required to make it a viable solution are simply not within our grasp at this point in time. For now, it remains more of a theoretical idea, a glimpse into what might be possible in the distant future rather than a practical option for today. If using antimatter to combat the black hole isn't a viable option, then what about considering its cosmic opposite, a phenomenon known as a white hole? White holes push matter and energy away instead of pulling it in. Theoretically, if we were able to create a white hole and precisely direct it toward the black hole, the interaction between the two could potentially neutralize each other's effects. The real catch? A huge obstacle we can't ignore. 1. White holes are purely theoretical. 2. We have never observed a white hole, and we lack any understanding of how one could be created. 3. A collision between a black hole and a white hole would release unimaginable amounts of radiation, likely wiping out life on Earth. While fascinating, it's not a practical solution yet. Instead of trying to destroy the black hole, could we redirect it? One idea is to use gravitational manipulation. Black holes can be affected by the gravitational pull of other massive objects, so it's possible we could use a nearby star or planet to change its path and redirect it. Another idea is to use immense energy to redirect the black hole, such as a laser or solar sail to nudge the black hole off course. But this would require technology far beyond what we have today. Even with these ideas, there's no guarantee we could act in time. A fast-moving black hole could reach us before we're ready. Let's get really wild, time travel. What if we went back in time to stop the black hole from forming? We could stop the star's collapse or redirect the gas cloud. Time travel is still theoretical, and even if we found a way to make it possible, it would create countless paradoxes and complex challenges that might be impossible to resolve. What if our past actions accidentally made an even bigger black hole? Another idea is using a wormhole to move the black hole to safety. Creating and stabilizing a wormhole is a monumental challenge that goes beyond the limits of our technology, leaving it as a concept rooted in theoretical physics for now. So, can we stop a black hole? Right now, the answer is no. Black holes are among the most intriguing and mysterious objects in the cosmos, challenging our understanding of physics and inspiring endless scientific exploration into the nature of space, time, and the fundamental workings of the universe. The best defense is avoidance. Black holes are among the most mysterious and incredibly powerful phenomena in the entire universe. They captivate the minds of scientists, sparking endless research and fueling countless theories as we strive to understand the deep mysteries they hold about the nature of space, time, and the fundamental forces that shape our reality. However, if such an event were ever to occur, humanity would strive to be prepared, leveraging all of our knowledge and innovation to face the challenge. Humanity will need to think bigger and bolder than ever before. Against a black hole, the normal rules of physics break down. And that brings us to the end of this cosmic journey. If you enjoyed exploring these ideas, don't forget to like this video, share it with your friends, and subscribe to our channel for more content about the universe. However, if such an event were ever to occur, humanity would have to rise to the challenge by thinking on an unprecedented scale, bigger and bolder than ever imagined. When you're faced with the power of a black hole, the rules of physics no longer hold up, and the very fabric of reality bends in ways we can barely comprehend. Thanks for watching, and see you next time. Let us know in the comments what you think humanity's best course of action would be against a black hole. Your ideas might inspire the next big discussion.